This is an overview for a 1 meter wide rolling platter build using V-slot 2040 aluminum extrusion. I filled the cavities of these two V-slot 2040s with BBs to add some extra weight and temporarily have these end caps on there to keep the BBs in place. I'll take the end caps off as I put the wheel plates on. The wheel drive system has a main axle of 8 millimeters in diameter, about the same length as the extrusion. So if you're using a different extrusion length, you'll want a different length, but mine is 1 meter long. And I'm using bearings, 6 bearings along that axis where the drivetrain pulleys are attached. The pulleys are 20 teeth and they're 8 millimeter bore to attach to these. One's at the motor connection and the other 2 at the wheels. There's one belt. The smaller belt fits at the motor, which is 152 teeth. The other 2 belts are on the wheels. Those are 240 teeth. I had a little bit of problem with the bearings I was originally going to use on here, which are on the wheels. They would not fit on here, so the tolerances are, I don't know which, something's out of tolerance, I'm not sure which, but these bearings actually fit, so I use these. So that's something to keep in mind, to make sure you have something that the bearings match the rod. An 8 millimeter lead screw would also work for this, or a 5/16 threaded rod of the same length you need. Which, for the wheels, I'm using 5/16 by 3-inch bolts. I've got one of them separated showing all the parts that fit on each wheel, and the other I've just kind of put together temporarily just so they can stay together. The wheel cavities and the bearing cavities for the bearings, they're designed at a diameter of 22.4 millimeters, which the bearings are 22. So some people have a tighter tolerance. That worked well for me. I still had to use a jeweler's file to file it, just to rough edges out a little bit. And all the T-nuts use M5 by 12 screws, except for 2 of them are 10 millimeters long, where they have to fit underneath the wheel motor. I've also designed 2 3D printed parts to replace the 2060 extrusion because I needed a really short length. I only needed short enough or long enough to fit this power supply and the carriage motor, the idler. The motor sits on. It's got 2 idler bearings and then the motor drive right there. But one of them fits on one of these and the power supply fits on the other. And that just worked out better than using cutting 2060 extrusion. There's also less parts you have to add, because all I have to have is M5 by 12 nuts. Now M5 by 12 screws with T-nuts on each connection, rather than adding some corners to it. The timing belt for the carriage axis was a little over 2 meters, so I used a 3 meter length to start with and cut it to length. This is all the electronics on this side, and this is a do-it-yourself power supply, portable power supply design I found, and I remixed to fit my design. It uses a Ryobi battery for the power, and you can adjust the voltage. I have it set to about a little over 12 volts. I'm using a Raspberry Pi 3B and a MKS Gen V.1.4 8-bit board with running Clipper, and a little servo motor that runs the pin up and down. The limit switches, I'm using these little board limit switches, and they're attached to the little plastic parts with a M2.5 by 12 millimeter screws. For the carriage axis, there's an idlers on each end screwed into the aluminum extrusion, so you'll need to tap at least one of the aluminum extrusions at both ends. The other one you don't really need to tap, so you need to have 4 tapped holes. I'm using F695 2RS idler pulleys for these. There's an idler pulley at both ends, and there's also 2 idler pulleys on each side of the motor drive. For putting this all together, these are all the tools that I needed to do this. I actually have 2 little 3D printed jigs, this one and this one, that help to line up the 8mm rod in the right place so it's centered. Once you put all those in, you put all the bearings in loosely, and then you tighten them into place because there's a little slotted hole. There's slots here and here, and on these 2 gray parts here, there's slotted parts for them. The timing belt for the carriage, instead of using zip ties, I'm using these little 3D printed parts that I made, little clips that clip on there. I use a PLA plus plastic, which has a little bit of flex to it, which works well for those. And all these parts I think were printed with Eccentric PLA plus or the Voxel PLA plus. The Voxel, looking at the data sheet, has a little bit more, I don't know how much flex, but based on the data sheet, it should have to be a little bit more flexible than the Eccentric. So I actually prefer the Eccentric for most of the structural parts. And I think that should about cover it. And this is just the overview. I'll get into more detail as I put this together. I'm going to start off this build with building 1 end plate, which is all of these parts, and 1 end idler pulley, which is this part here, because they kind of go together. This one won't take very long, so we'll just do this one first. But what you'll need for your hardware is 2 M5 by 25mm screws for the idler pulley that attaches here, these 2 holes here, 2 slotted holes. This is a little spacer to give it a little bit of room, and this is the idler pulley there. The other idler pulley is connected here, and I didn't use a spacer there. But you also need 3 M5 by 20 screws, 2 here and 1 for the idler pulley. For the idler pulley, you also need 2 M5 by 16mm screws to screw into the tap holes on the 2040. You could use a different length if you prefer. I use 16, which it seemed to be a good number. And you also need these F695 2RS idler pulleys with a 6mm spacer. For all the T-nuts connected on the back plates, in the back plate and the front plates, you'll need M5 by 12mm screws. So you need 1, 2, 3, 4, 5, 6 of those, and 6 T-nuts as well. This main plate, I cut it off so I could give more carriage width. That's why it looks a little different than this one, because it seemed like it only needed 2 screws to hold it in place, because everything's kind of held together, so it seems like it had enough structure there. For each one of the wheels, you're going to need 6 O-rings, and they're in the bill of materials which size they are. And this is a 240 tooth drive pulley. It's a closed loop timing pulley, 6mm wide. I'm using I'm using 5/16 by 3-inch bolts here. You could also use M8 by 70mm bolts. I'm using a washer on one side where the bolt comes through, and 2 on the other side with a lock nut, and 4 bearings, which are the I forgot what those are. Those are the skateboard bearings, and these 3 be printed parts. This one goes in the center to connect the two bearings to keep them from getting compacted together. And I already left the O-rings on this one over here, so I didn't take those back apart. That should do it. Alright, let's start with the idler pulley. Let's see. We're not going to put the end screws in because they go in later, but I just put them out here so you could. Alright. So here's the idler pulley. I think I have it centered in the camera. Sorry, that didn't go in there like that. Got to put the spacer in first. Spacer. One half of the bearing. Other half of the bearing. You make sure they're pointed that way so the belt goes between them. Yeah, screw on top. And this is slotted here. It's kind of difficult to tighten it. I pretty much get it tight. So I kind of move it to the closest part to begin with. And we probably you don't really want it tight anyway, you just want it on there because we're going to tighten them up later. So let's unloosen that a little bit so it can move freely. And we'll tighten that up when it's done. And we won't put it's pointless to put those 16 millimeter long M5s in there because they're going to come out. Alright. Now we'll start with putting the O-rings on. They just kind of start at one end and just kind of slide, just go over all of them. Or you could do 3 from one side and 3 from the other, but they go on quickly. Or you can also 3D print a TPU tire if you want to put one design up there. There may be others down the road that somebody else comes up with. So 6 O-rings should give it a lot of tread. Okay, they're all on there. So first off, we want to put this big spacer in the middle. That just fits down in there. And you want to make sure that these have a fit. Before you print all these parts, you might want to do a test part of just a short height of this to make sure your bearings that you have fit well. And I have them, you kind of want to have a nice, as tight a fit as you can. These are maybe a little looser than they should be, but because I can pull them out, because I kept pulling them out and changing them. So, and that's the main part of that. So you got a bearing on each side, and one of these pulleys, one of these spacers in the middle. Now the short spacer is going to go closer to where this teeth are, which is close to the main plate. So we can't put that on there yet though. Let's put the other wheel together. Oops. Started going sideways. Sounds pretty tight fit. The tighter fit you have, you're gonna get better traction, I think, or less wobble. All right, so that takes care of that. Now let's put the idler pulleys on. And these can go either way depending on which. I think I put the nuts to the inside. Work better for me. So these are the 25 millimeter long bolts. And you may or may not need this spacer. I put it on there, but I didn't use one on the main one. Just seemed like it might be a good idea. Because this part here is going against that. Oops. So you do want to make sure that the part that you can see all the bearing goes against that. And we're just going to put these on hand tight. We're not going to tighten them all the way down because we're going to need to loosen these when we put that axle rod on there. Okay, that gets that plate on there. And this is going to be and there again, this one, the bearing, the part you can see all the bearing wants to go against that face. Oh, did I put that in there wrong? Actually, it should be, this bearing hole needs to fit with that slot, so I put the other one in there backwards. And these are the 20mm long screws. I'm 5 by 20mm. Let's take this back off. Both have to come off. Just that. Okay, now we swap it around like this. The long screw. There it is. And the bearing that you can see, the whole bearing goes against the face. Again, they're just hand tight because it wants to be able to slide back and forth to adjust the position. All right, now we're ready to put the wheels on. So I'll mark this one because I wanted to know which one was the way I had it built before, but you want to make it's not as important on the first one, but the second one you want to make sure that the, well, at least you should, I think, have the drive belt on the same side, so it's on the mirrored side on the other side. So let's see. I'm going to start off with a bolt and a washer. Goes through one plate, and this is, that's the way that goes. Then it's the really short washer there, goes there. You want to have the tapered end close to the bearing, so it rides on this inner race of the bearing. Oops, bearing coming out. Then we have the taller washer on there. 20/20 hindsight, I should have made this more symmetrical so the bearing, those spacers were the same on both sides, but that's the way it worked out. And one thing to make sure you do is to put the belt on. You could put it on maybe, you have to put it on before you put the other wheel on, but you may as well put it on now. Otherwise you'll have to take it apart and put it back on there. But it needs to go in place before, just kind of in there, before you put the other wheel on there. Okay, and then it just goes through there like that. And this one we put 2 washers and a lock nut on. And we'll just hand tighten it until we put the other wheel on there. Okay. Now the other one we put washer on first. Let's move that stuff out of the way here. This one you can kind of move that one away from the side for now and just kind of put it in there like that. Oh, sorry. The tapered end's got to go to the bearing, the shorter diameter. Go like that. Then we have the other spacer with the tapered edge towards the short tapered edge towards the bearing. Now we can put, there's enough flex in this plastic to be able to do that, but some plastics may not be as bendable, which some places might be better anyway, but anyway. And we put all the T-nuts on near the, when we're getting ready to put it on there, because they're kind of a pain to put on there if you don't do them at the right time. So I've got, since this is a 5/16 bolts, I'm using a 1/2 inch socket and a 1/2 inch wrench to put them in place. And these you can go ahead and tighten up. Might tighten that a little more after I do this one. And that's it, except for putting the T-nuts on. So there'll be 2 T-nuts on the main plate. This is the one closest to the carriage, and this is the back plate. The ends of the extrusion come in here, so those connect on the sides. And one of these goes, this belt is going to be on the back wheel, so this will be on the front like that. And that's it for that assembly. I'll put those T-nuts. I just added them to the list because that's what you will need for putting these together. Okay, I did the other side off camera, so you don't have to sit there and watch the same thing. It's essentially the same thing, except you can see the belt is a different spot. It's just a mirror image of the other side. And the idler pulley is the exact same way as the other one. There's just not many parts on that. And that's it for the wheel assembly and the end idlers. Okay, the next assemblies we're going to put together are the 2 idler bearings that are close to the drive motor. These are the idler bearings. They've got 2 M5/16 screws with lock nuts to mount this to this part, and they have 4 T-nuts with M5/12mm screws connected to the V-slot. We won't add those at this point, but I'm just showing them here. So we've got 2 sets of those. So you get actually 4 M5 by 16 millimeter screws, and then you've got 8 T-nuts for both assemblies. And we're also going to do the drive motor with idler pulleys assembly as well, because this is sort of not much to all of this. And that has 2 M5 by 25 millimeter screws with lock nuts with those same flange bearings, and 2 tapered 3D printed parts. You could actually use those 6 millimeter things, I believe. I think these are the same length, but I'm not sure at this point. I'll have to check. I could check that later. But I would use these. These are a lot simpler to put on there anyway. And it's also got 4 M3 by 10 millimeter screws to connect the motor to this. And we'll connect the motor first because it makes it easier to do the rest of it. Easier to put the bearings on there after. It's more difficult to put the motor on there after you put those flange bearings on there. And we will connect these T-nuts on this one because these you can kind of slide in. It's easier for me to put the T-nuts into the V slot and then connect them later. But these, it works pretty good because they're going in that little small 3D printed 2060 part. So you want to kind of give an idea which way you want your wire to come out. And this is this is also, you're also going to have this pulley. I've already put it on there, so you'll have to get that, and you'll need a little Allen wrench to tighten it to where you want it. But I've got it. It's about the width of that from the top. It's about where I have it set. But you put it in there loose, and then you tighten it once you see where these idler pulleys are located. But it should be about right there if you're using the same motor. But your shaft might be a little different length, so that's probably not a good thing to go by. So I'm gonna have the wires coming off the back. The slotted part is towards the carriage. Oops. It doesn't really matter which order you put these in. I'm not tighten them all the way to begin with. Okay, that's the motor's mounted. Just tighten it down all the way. Now it's time for the idler pulleys. So you got the screw goes in from the top. One spacer in there. One flange bearing, now the other flange bearing. And these we will tighten all the way because there's no adjustment on these bearings. And I'm using ball driver screws because they're a lot easier on some of these parts. I haven't come into a condition yet on this, but later on in the build I think you'll notice they come in handy. I usually size these M5 holes so it just pushes through there. Well, there it went that time. But these, I gotta thread them in a little bit. Oop, wrong way. So the flanges are like this, so the belt goes between them. And this is the point where you can adjust the grub nuts on that motor, because you should be able to see how it's lined up on those. Actually, it might be a little bit off. I might need to change it a little bit. I think I'll adjust it a hair. I just do kind of a visual on that. It should be pretty close. That looks good. And you put one of the grubs. Some of these motors have a flat spot for the grub screws to attach. So I have one of them attached there, and the other one is just on the round spot. I have some motors that don't have that one, but this one does. So now we'll go ahead and put these T-nuts on there too, because this is alright to put them on there now. And you don't want them all the way on there. Well, you could put them on there all the way tight to begin with, and then you'll have to loosen them before when you put them on the machine. It might be good to have them tight on there while you have the sub-assembly, so they don't come apart. Yeah, all I got to do is take them off, rotate them a few turns to. And if you can see, the large part of the T-nut goes to the inside. Yeah. Oh, right in there. Okay, that takes care of the motor and idlers for the carriage motor. Now we'll work on these. So, if you can tie this, I think it goes back left. That's where it goes. Alright. I have to think about it a minute because this one's could be a little confusing. So this is the way this connects on there, and that's these slotted holes. This goes back and forth like this to adjust the location of it. And I put the screws from the top down to the bottom, and these you're not going to tighten either. You just put them hand tight to begin with because you have to move them. They should end up in the center of that slot. At least on my build it does. And well, they should, yeah, because I'm going to use those little jigs to center it. Alright, that's one together. We'll tighten them just a little bit so they're not really loose. Yeah, and I also redesigned this part to use so this head is recessed another 2 millimeters, so you can use 15 millimeters, because actually these 16s are a little bit shy of going all the way to the end of there. Oops, I tightened it too much. Okay, now it's loose. Now the other one is the same way. You see, I've already put the bearings in here. I didn't want, because these were pretty tight fit. I didn't want to pull these back out. But as you can see, that the whole bearing wants to be to the inside here. That's the way I had it. That's the way it's, well, that's the only way it will go actually in this particular case. Okay, that completes. Okay, this is the assembly for the motor that drives the 8mm axle between the two sets of wheels, and we've got 4 M3 by 10mm screws to mount it to the plastic part, and we got, in this case, we actually have 2 M5 by 10mm screws that go underneath the motor. And as you see, there's a couple of recessed, they're a little recessed for that. And these actually work better with the ultra low profile. They will probably work with these button heads. I like the button head ones because I got used to using those on my 3D printer builds. And the other 2 screws for the V-slot are going to be the M5 by 12mm. And we'll add the 10mm links to begin with. I don't know that we'll add those 12s, but maybe we'll just put them on there just to have them out of the way. And this also has a 20-tooth pulley with the M5 bore. And this one's not so important where it goes on here. You just want to make sure you're not all the way up against the motor. So you got to have at least a little bit of a gap there, because this one you can adjust. It's kind of varies because it's not dependent on anything else except for the 20-tooth pulley on the axle, and those will be moved once you get them in place anyway. So first we want to put the M5 by 10mm screws in, otherwise you won't be able to get them in there. So we'll put them, and we'll put the T-nuts to hold them in place. And I've kind of cut the plastic to match the V-slot extrusion, so they kind of go on there a little better, but so they stay in one place once they're on. It gives it a little bit more support, I think. Yeah, we'll just tighten them all the way down to keep them on there. And we'll just go ahead and put these on there too while we're at it. They'll come off once, these T-nuts will probably come off once we start to install it. But they'll be all together. Okay. Now these actually have a slotted on them so you can adjust this motor some. And you want to make sure that your wiring comes off either the back or the top. I think probably the back is what I so I could put a bigger, a thicker plate for the plastic on there. I'll have to loosen these a little bit because you want to be able to adjust the motor. So we want to have the motor closest to the center between the two V-slots. I'll be able to, oops, should slide. Something's too tight. There we go. So I want to have it to this location to start with. I'll go ahead and tighten them up a little bit because so they don't come on. Just a little bit tight. And that's it for that assembly. Okay, I think this is probably going to be the last sub-assembly before actually starting to put it all together. This is the carriage assembly. I'm not going to take this apart and put it together because it's a lot to it, but I don't want to mess with that again. Where that one came out. Oh, that's one of the T-nuts that came out. But it's connected with, I only used two T-nuts with an M5 by 12 to connect to this vertical V-slot, which you'll see on there in a minute. But it uses a servo, and I've got a 1 meter extension cable on it, since the servo one comes with a very short one. And it's got a couple of springs on there, and these are little smooth rods out of an old DVD player. There's a link on the site for this. But I'm using that Open Build's little plate for the 2020 extrusion because I'm only, even though I'm using 2040, I'm using the 2020 part of it. So it uses 4 wheels. The screws it uses, on the bottom ones it's using 30 millimeter long M5 by 30 millimeter. On the top it's using 27 millimeter long M5s. You could use 30 millimeters for all of them. You just have to put maybe a couple of more spacers in there. I think that would work. And we got 2 eccentric nuts on the bottom and 2 6 millimeter spacers on the top. And I also have 2 M3, but I think they're 12 millimeter long. I'll put this here. M3 by 12 millimeter to also connect between the slot and this V-slot and these little 3D printed parts. That's to kind of keep it from bending. And this is the little mount that goes down the center of this V-slot that holds a little short V-slot 2020 in place. Let's see, where do we want to start this from? We'll start with the wheels, I guess. I think it was the long ones went on the bottom. We'll see in a second. On these wheels I also have a little washer on the ends just to give it a little bit more extra length. Those are going to be a little, is that right? Maybe I used the 27s on there. Yeah, the 30s go on the bottom. Oh, I'm sorry, the 27s go on the bottom. The reason I need the 30s on the top is because I got this extra bit of plastic that the screw has to go through. So that's like 3 or 4 millimeters thick. And these T-nuts, I've marked the, some of them come with a little mark on them, but I put a little Sharpie mark on the wide part, so I want to put that to the outside so you got so you can tell where each T-nut is actually located in this revolution. And these can be tightened on down. Where did the T-nut go? Or the, oh, there it is. And you also notice that these will have a little, it'll be pretty obvious which way that the T-nut goes in there, because this part wants to, there's a little rounded part that goes into the metal. And this will want to be put on there before you put, after you put the first end plate on, but before you put the last one on, because that way it's easier to slide it on versus you have to take 2 wheels off and then put it back on, which is a little more trouble. That goes in there and fits into the hole. And the washer goes to the outside. I have to have the smooth side against the bearing. And this screw actually fits for the adjusting that, so I'll move it to the, so the red part is to the outside. That one's not very tight. Okay, that's the bottom. Now, the top, I don't know that we need to put that on there yet. I think that can go on there last. This is where you want to, these are 2 different, you see them a little bit different. This has a little part here to hit the limit switch, so that wants to go on this side. Like so. I got a place for 2 M3 screws, but you only need 1 because they got the M5 to hold it in place for the other one. And this, you want to put the M3 in there first because it's a little more difficult to get it in there if you once you get the wheel on there. It's a lot more difficult. I usually use the bottom one. I don't know that it really matters, the bottom or the top, whichever you prefer. It just has to have another 1 screw in there to hold it in place. Yeah, we'll go ahead and put both of those on there as well. Okay. like this little wrench. It came with my first 3D printer many years ago. Yeah, you see it's gonna, see that's why you need 2 in there to keep it from doing that. But yeah, once you, whoops. It's actually in a slot, so I need to slide it down for the M5 to fit in there. Okay, now we're ready to put the other wheels on. Actually, I probably should have tightened them all the way down and make it easier to put the M5 screw in there. Just loosen it up just a little bit. I also made a 3D printed part for this whole assembly. I don't know that I'll put it in with the build this time or not, but if somebody's interested, we'll put that on there. So this has the 30mm long screw because it's got the extra distance to go. Plus it's got the 6mm spacer, the wheel. And I didn't use a washer on the other end because I didn't really need it for the length. I only used the washer to keep this screw from going too far through the lock nut. Yeah, see with that loose, those screws go in there real easy. Another spacer, another wheel. And I use these wheels. There's different, I think these are the best wheels, the extreme ones they have, but you can use any version you want. I just thought these would be good to try on this machine. And these you can tighten all the way down. Oh. On one, that's the bottom. It's already tight. And see, it's still just, oh, that's because I don't have the M3 nut. So you want to kind of line these up so they're kind of parallel with the top of the plate. So now we can tighten up the M3s. There's enough room to tighten those once you have the nut on there. I believe there is. Just barely, yeah, so I probably should have tightened those up once I got the M5 screw in there because they are a little tight to get in there. It looks like it's holding. Alright, one more part to put on there. This, two more, I guess, the plastic part and the extrusion. So this is an M5 by 16mm screw. And you could make this spacer wider or narrower, I guess. I think that was about as narrow as I could make it. So you could use longer screws or oh, this will have to be a little loose to get them in there. Okay. So this just slides through the V-slot on one of them. And this V-slot is about 125 millimeters if I recall. I just cut a 250 millimeter length in half. And it's not, I cut it with a hacksaw, so it's not really a nice clean cut at the top. And so I think I usually have it, to start with, I just have it so at the bottom, just so it doesn't, it's easier to move around. But with these T-nuts you have some adjustment. You can adjust this up and down by moving those T-nuts. And then this you can also adjust up and down along, which you have here already with the T-nuts that's on there. Let's go ahead and put that on there too. I usually put one on the bottom and then on the opposite top. Let's see. So this goes, and that way it's easier to get these T-nuts. Trying to do two of them at the same time is a little more tricky than one at a time. So then that can go up and down like that, and this can go up and down like that, so you got a lot of variation there. And you could also use a longer V-slot as well, but it might get a little bit more cumbersome doing that. This seemed like a good length because I didn't really need much movement. And I think that's all of that. So we got the little red markers on the outside underneath. That's the furthest away from the extrusion. And so we'll tighten that once we put it on the aluminum extrusion to see how well it works. Actually, we'll tighten this. To get this, we'll just use a little scrap piece of V-slot 2020 to get those wheels pretty well close to where they need to be. That way we'll have to tighten it much when we get it on there. So you can probably see how loose, it's pretty loose like that. So we want to tighten each one of them the same amount. Not quite enough. That's pretty cool. I can feel it grab just a little bit when I put it on there, so that's a pretty good feel. You can tell if it's floppy or not. And that's the advantage of using this metal one versus a plastic one, because the metal one is a lot stiffer connection than the plastic one sometimes is.